Christian, while I have you, did you see in the news about the giant ring of galaxies? It's astronomy news.
So I've discovered a really massive structure in the universe. So these are the biggest things in our universe. So it's made up of galaxies and galaxy clusters, and it creates this really big ring shape.
Yeah.
What's your take as an astronomer on this find? Do you think it'll change our views of the outer cosmos?
I think there are some information missing because those galaxy clusters, I'm into that matter for some time now myself. There are parts in the universe where you have galaxy clusters, and there are much larger parts where you have nothing. They are called cosmic voids. We are living with our own galaxy cluster at the edge of such a void. I did some workshops about voids myself in 2022. The astonishing thing is that not the galaxy clusters are the things that drive the universe, but the voids are. And the creation of galaxy clusters is not understood well. And therefore, these new informations, they are a further step to understand how masses are produced.
Chris Lehto, welcome to LehtoFiles.
Welcome to LehtoFiles. I'm here today with a Sky 360 update. So Sky 360 actually won our contest. They won. NFT holders from UAPSociety voted, and their project actually won. So Sky 360 founder Richard, and we have lead astronomer Christian here today. Thank you so much, guys, for being here.
Thanks for having us. Great to be with you again.
So, Richard, we have AI coming on board. It sounds like this global supply should hopefully be improving. So how was your 2023 and what are you looking forward to in 2024?
Yeah, so basically I want to make a statement to the audience so that everyone is aware of where we are and how we came here. So, when we started Sky 360, nobody built such a system before. So we had to learn. And during this learning curve that we had in the last year, 2022 and 23, we had a lot of developers, around about 40 people, developing stuff. We had a lot of experiments, things we tried out. So to make it short, in fall last year, we had to decide which direction to head to. So we knew what kind of methods best to bring on into the future and what methods we had to get rid of. This was a major decision within our organization, meaning we had to switch from a pure experimental mode into a production mode. And by that, leaving some of the experiments and outcomes behind us. That was not very much appreciated from some people, so they left us. But that's okay. We are an open source and open community. But at a certain point in time, we have to make decisions. We cannot make a system that can do everything and boil coffee, for example. So we had to focus. The decision was commonly made to go for a robotic real-time system.
This is the ROS, right? Robotic Operating System?
Yes, exactly.
Okay.
It's a real-time system that allows us at the end to do sensor fusion, because it's like a human being. We have a lot of sensors, and we have to fuse that together and to have one decision maker that sees all the sensors' results. And that needs real-time features, that needs robotic features, meaning self-control and self-healing methods. In order to move into that direction, into real-time and the robotic system, we had to start building the infrastructure, therefore. So infrastructure meaning we need a operating system that we can control, that we can easily create images that we can then share with the community and testers, and implement also the real-time environment. And our head of software development, Ido, is concentrating on that since September last year, I think. And yeah, our progress is that we have the operating system running. We can create images. The ROS part is created, is enabled. Christian, please correct me if I'm wrong. The things around about the driver for the camera and the firmware are still in progress, are still in work.
Yep. because based on the chosen operating system for the actual hardware, we are setting on Orange Pi 5 at the moment. There are some issues with getting the driver to load at start. Yeah, this is where we are staying with that. The heartbeat system of Robotic Operating System 2 is working and delivering the main event loop to it. This is working. At the moment, we try to get the cameras up and running. That's a little bit difficult because the original drivers were not set up for that and had to be modified to get them running with NixOS.
This was the big change, right? This was the big change
Yes.
is going into these different kind of computing systems,
Yep.
right? So you can buy little Orange Pi 5s rather than have a much larger like CPU, right? Is it kind of decentralize the computing is what I understand is kind of what you guys chose to do. Is that correct?
Yes, exactly.
During our experimental time, we found out that we need much more performance to record it because the images from the astronomical camera that we're using are so huge. So that with the first approaches, that was not possible to get the images from the camera.
Okay, yeah, that's the biggest problem. Yeah, I think Richard mentioned that is a big problem is you have to have onboard kind of processing is what I understand, that real-time processing, because like you mentioned here, these sensors, you guys are using much larger sensors, right, than your phone camera. So it's going to create huge data. So what do you do with that data if you have all that data coming into one large, expensive brain? It's too much data. So what you need to do is kind of use AI processing. And from what I understand, please correct me after this, Richard, but you want to use AI processing to minimize the amount of data. So it's actually processed here. Oh, that's something critical. Now we're going to save that. Is that, I understand the ROS robotic system allows you to do that?
Yes, basically it does. The thing is that our choice was going for a raw system that works on the raw data when the photons hit the camera, the chip. And this creates a huge amount of data because resolution was our goal. And resolution means that you get from everything that you want to detect the maximum. And therefore, you have to use a data reduction system. This has to be run before everything so that you can make use of the data that you collect. And therefore, at the moment, because of the quality those sensors got during the last years, we need much more performance and much more power to get the data from the sensors. Not even the CMOS sensors, but everything. And these had to be in line with the timing, and that's where ROS 2 comes in to have a heartbeat about it, to deliver the data, to reduce the data and everything like that. So that you then, after the pre-processing, get data that you can put into, let's say, a neural network for detecting things.
Interesting. It reminds me kind of the F-16. Like on the F-16, we called it the flux bus. I think it was like a 1356 data bus, they called it. Kind of reminded me of that, is where you have these components just need to be able to communicate with the main system, if you will. And now you create. It sounds like the sync. Yeah, that makes sense. So the timing is what that really benefits.
Yeah, and you really have huge data sets at the moment. One image that is collected in 16-bit has around 50 megabytes. And if you say, okay, 25 images per second, you can calculate it and you can add it up, and you see that the data transmission to that is very huge.
Astronomical.
So, because that's why we're using astronomical cameras. And of course, these data throughput has to be managed. And USB 3 is the least we could do because at the moment, those cameras don't deliver with 12G SDI. So that may come one day, and then we have to be ready for that too. So we made a big choice about it, and we said, okay, we have to go for the maximum raw resolution that we can get. And that's why we did those choices.
Max resolution.
Not everyone was satisfied with it because, of course, sometimes you don't understand the things that have to be done in the background. like this data reduction to get the most quality out of it. That's
Well,
one of the things. You can't corrupt physics, and you have to deal with it, that you can't corrupt it. And there is no easy way to do it. Just do it right.
And I know Elon Musk famously said that prototypes are easy and production is really, really hard. And so I think you guys are running into that, especially with the open source community. You had 40 developers. You're going to have to make design decisions, right? I'm sure you're going to anger people. So it sounds like you guys are working through those issues and getting to a design. So how far along is this design? We were talking a little bit before, Richard, like I'm going up to Hessdalen next month. You mentioned in the US, there were some people interested in putting out these systems. You know, what do you recommend for that people want to get involved now? Is this system ready to order? Can they start ordering the parts and building it? What do you recommend?
So basically, there is no company selling this stuff as a complete box. So everyone who joins us or wants to set up a Sky 360 station has to be aware that he is developing with us. So kind of an alpha tester, beta testers. So yes, you can start. We have layouts. We have our create list of hardware. You can start acquiring material, set it up, but be aware that our updates are not necessarily always stable. That's implicit to beta testing. So we have to learn from these people. And yes, we encourage people to do so. So we have around about, I think, 25 people in the alpha stage. They download the image, put it on their Pis, and boot up the system and see what happens. Some can run it for several days, even weeks, and give us feedback so that we learn what is needed under certain circumstances. Because, you know, people build their stuff themselves. It's not one company creating something with a quality assurance at the end. So we have to learn how people build their systems and learn from this. You know, it's a ping pong. We learn from them, they learn from us. So that's something that we encourage people to do so. Don't expect us to be a company where you buy it and it's right out of the box. No,
Yes.
When you start working with us, you have to be aware that it is still in development, and it always will be. We don't see the product as one time we have one time a version 1 or a production version, but it will never be finalized because we will always add new sensors, new features, new software, new methods. It will be an ongoing process. So when you decide working with us, be aware that it takes time, but the results could be very interesting, especially on places where there's activity.
Yes, excellent. I recommend everyone go to sky360.org. This is their website. It sounds like they are making definite progress. If you want to get involved as well, build out one of your own systems, right? You can build it. It's all open source. So I would recommend everyone to go to sky360.org. Anything else they can do, Richard?
They can meet us on Maker Fairs. We have been on 2 Maker Fairs in the last year. It was Maker Fair Vienna. That was our first approach to that. We may have some photos to spare. And the second one, which we managed to set up a little bit better than that. This is what you can see in this video. We got interviewed at the Maker Fair at Hanover by the Tuxedo guys who are building those nice and robust graphic laptops. And they asked us to give us a small interview. And we did that right out of the box. And as you can see, we try to explain what our system does, what the goals are, and where we stand. And as you can see, this is a station in the alpha state we put together that's working already. To the right, where Oliver stands in front of it, we have a live feed of the image sequence, and we explained that to them. And so, we are at the stage that we can deliver image sequences, and we have to get just better, I would say. And this is
so it sounds like there's definitely a working prototype, and you guys are just getting through that difficult stage of moving it to production.
Yes. We try to put it out there, and this is what we have taken our goal for 2024, that we reach the production stage.
Excellent. I think this is the year.
Yeah, that's definitely the year.
Hope so. And while I have you here, sorry, Christian, while I have you, did you see in the news about the giant ring of galaxies that was found by the UK PhD student. It's astronomy news.
Yeah.
What's your take as an astronomer on this find? Only because I'm covering it later. Do you think it'll change our views of the outer cosmos?
I think there are some information missing because those galaxy clusters, I'm into that matter for some time now myself. There are parts in the universe where you have galaxy clusters, and there are much larger parts where you have nothing. They are called cosmic voids.
Voids.
We are living with our own galaxy cluster at the edge of such a void. And this, I did some workshops about voids myself in 2022. And
Cool.
the astonishing thing is that not the galaxy clusters are the things that drive the universe, but the voids are. And the creation of galaxy clusters is not understood well. And therefore, this new informations that show this galaxy ring and stuff like that, they are a further step to understand how masses are produced, how masses evolve, and what to expect when the voids get larger and larger and larger. And the voids are the ones that drive such systems and those filaments of galaxies. And the filaments interact, and the galaxies and the galaxy clusters within interact. And this is how we should see what's happening. And just leaving out the voids, because these are the motors of it, doesn't help. And you have to see the universe as a whole, as not just look there and see things separated from each other. And yes, so these new informations will help to get a better understanding.
Oh, interesting. Yeah, some of the structures are 1.3 billion light years across, basically larger than could have formed from our current understanding of the galaxy. So I think it's quite interesting. Just curious to get your take on it.
Yeah, it's about 10% of what is actually considered to be the size of the universe.
Yeah. So how could something that's 10% of the universe grow within the universe in that amount of time? I think that's the argument, right? It doesn't make sense.
It makes sense if you don't leave out the voids, because the voids created such a structure, because the voids are emptying themselves and creating larger voids. The voids are the things that drive the system, not the galaxies and not gravitation, not dark matter, which is just another form of gravitation. The voids, they are pushing everything out of it. And this is how the understanding of matter should be, because the matter is falling from it, is driven out of it by the curvature or the missing curvature of the voids. This is driving the things.
I see.
Not attraction.
There was one final point they said, is that our assumption of the larger universe is that it's uniform. And I think what you're saying there is that it's not uniform, right? These voids are actually, it's structure that we're not expecting.
Yes, but it's found by Thomson and Gregory in 1978, and they made it quite clear. Brent Tully is working on that and did some nice work, just to name, if you want to look them up. I think it's necessary to not leave things out and go for the complete information set.
Yes. It's easy to leave out information that's not convenient, right? That data point that you don't want, that doesn't match your regression line. You don't want to put that data point in there.
But in this case, it adds up, and it gives the explanation that we needed about it to understand it. And therefore, yes, I think we started a new approach of changing the whole scientific history.
Cool.
If we can contribute with Sky 360 as a citizen science project, that would be awesome.
Excellent, because you guys will have the high grade sensors. What I like about this project, I love it, is that the final goal will get the solutions we want. I think it's an ambitious project. It's very ambitious, and I really appreciate that you guys are going for the best possible solution. Worldwide coverage with these high grade sensors. So I'm sure we'll get data. So I wish you guys all the luck. Yeah, in 2024.
The thing is, we're going for the science instead of going for rumors or narratives. And everything that we can detect or sense without using human senses stands for itself and can be watched and looked over and it stands for itself. It's a beautiful situation because nobody can point and say, okay, he made it up. Because with all the sensors, they are achievable, they are affordable. Everybody can take them. That's why we try to be as transparent as possible. We say, okay, try us, build the system, take a look at it, try to find it yourself, and not believe in the narrative that's out there. This is our strength.
Yeah, I totally agree. The second place winner in the contest, Ryan Wood, actually his idea was just to have kind of what you said, is interested people just build their own systems at home, like become sensors, as you will. And that's where, don't believe us, build your own system and capture your own data. And then, no one faked it, no one hoaxed it, because you cut it yourself. So I kind of see this 2024 as hopefully a combining of those two project ideas, right? Yours building the actual system, and then Ryan's, which is getting motivated people out there to just go and look for themselves and try and change some minds. And I guess a lot of the, like that breakthrough, right, for the ring galaxies, that was found by a PhD student. So it seems like we're just going to get more decentralized science as these breakthroughs just keep coming from not the mainstream,
Yeah,
true.
All right. Well, excellent, guys. Good luck 2024. All the best. All the best. Thanks for being here. Thanks, guys.
Yeah, thanks for having us, and thanks for running your show and the UAPSociety, and cheers and greets to the members there.
Excellent. All right, guys. Have a great rest of your day. Peace.
You too.